In the previous class, we have studied about parallel plate capacitor. Now we know what is a parallel plate capacitor and how to find out the capacitance of a parallel plate capacitor. So let us take a problem to find out the force on each plate of a parallel plate capacitor. This is basically a derivation. Let me give you the question first and then we will derive it. Show that the force on each plate of a parallel plate capacitor has magnitude equal to half QE. Equal to half Q into E, where next you take down where Q is the charge on the capacitor and E is the magnitude of electric field between the plates. Explain the origin of the factor half. Explain the origin of the factor half. Show that the force on each plate of a parallel plate capacitor has magnitude equal to half QE, where Q is the magnitude of the charge on the capacitor and E is the magnitude of the electric field between the plates. Explain the origin of the factor half. We will derive this equation. Now, in the last class, when we derived the equation for capacitance, we found that, so we took two parallel plate capacitor and we assume that distance between the plates is D. The distance between the plates is D. And we said D is very small compared to E. D square is very small compared to A. And in that case, these two parallel plates can be considered as infinite plane sheet of uniform surface charge density sigma. So the surface charge density is sigma. So these two plates, with the assumption D square is very less than A, two plates can be considered as infinite plane sheet with surface charge density sigma. So while finding out the electric field, we have used the formula which we have derived for the electric field due to infinite plane sheet with the uniform surface charge density sigma. So we will use the same thing here, and we found that the magnitude of electric field between the plates of charged capacitor is plates of charged capacitor as capital E is equal to sigma by epsilon naught. sigma divided by epsilon naught. So E is sigma by epsilon naught. This we have seen. So this is the field between the plates. However, if I consider magnitude of electric field of one plate on the other, then we get it as sigma by 2 epsilon naught. Because once we know the electric field, we can easily calculate the force. Force is nothing but Q into E, we know. So now I can write here magnitude of electric field of one plate on the other plate of charged capacitor is so let me take it as E1. E1 it's equal to half of E, that is sigma divided by 2 epsilon naught. So this is magnitude of electric field of one plate due to the other. And we know force is Q into E. Now you consider force. Force on one plate of charged capacitor due to the other is force on one plate of capacitor due to the other as F is equal to Q into E1, Q E1, because force is Q in electric field multiplied by charge. F is Q into E1, so it is Q into sigma divided by 2 epsilon naught, or I can write Q F is equal to half into Q into sigma by epsilon naught, and which is the required equation. F is half into Q into sigma divided by epsilon naught, and we know sigma by epsilon naught is E. Substitute sigma by epsilon naught equal to E. We can write here substitute so let me take this equation as 1, this equation as 2, and this equation as 3. Substitute equation 3 in equation 1 in equation 3. What do we get? F is equal to half into half into Q into E, which is the required equation. The force on one plate F is, the question was to derive the same equation, half Q E, where Q is the charge and E is the electric field between the plates. We have derived the equation F is half QE, and there is another question that is half QE, so we derived this. Then explain the origin of factor half. So this half has come because the electric field of one plate due to the other plate is half of the resultant electric field E. If we see here, sigma by epsilon naught is the resultant field. So half is because when we are considering field of one plate due to the other. Finally, we can write here the term half, the factor half is because the electric field of one plate on the other plate of charged capacitor is half of the resultant electric field. E, half of the resultant electric field E between the plates of charged capacitor. So this is the answer for the last question, why the factor half has come. The factor half is because the electric field of one plate on the other plate of charged capacitor is half of the resultant electric field E between the plates of charged capacitor.